Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to solve another problem. The problem goes like this. The problem says a light year is a measure of length, not a measure of time. Equal to the distance that light travels in 1 year. That question says compute the conversion factor between light years and meters. And second part of the problem says find the distance to the star Proxima Centauri, which is 4 into 10 raised power 16 meters in light years. Check the question. A light year is a measure of length, not a measure of time, equal to the distance that light travels in 1 year. Compute the conversion factor between light years and meters and find the distance to the star Proxima Centauri, which is 4 into 10 raised by 16 meters away in light years. So let us move to the solution. First, understand the question. This question gives you first some information. You can understand. It gives you the definition of light year. So this is one information. Light year is a measure of length, is a unit of length. It is not a unit of time. And its definition is, it is by definition the distance that light travels in 1 year. That much distance is called 1 light year. So it's first information. Second information gives you about this star. There's a star called Proxima Centauri, which is 4 into 10 raised by 16 meters away from us. We have to do. We have to first find the conversion factor between light years and meters. Second thing, we have to find this distance to Proxima Centauri in light years. That means we have to convert this distance, which is given in meters, to light years. So let us move to the solution. First, we will find the conversion factor. So the conversion factor from years to seconds is 1 year is equal to 1 year multiplied by 365.25 days over 1 year multiplied by 24-hour over 1 day multiplied by 60 minutes over 1 hour multiplied by 60 seconds over 1 minute. Understand this. I'm writing 1 year is equal to 1 year multiplied by 365.25 days over 1 year multiplied by 24-hour over 1 day multiplied by 60 minutes over 1 hour multiplied by 60 seconds over 1 minute. This is simple. I am multiplying 1 year by 4 ones. This is 1, this is 1, this is 1, this is 1. Why so? Because 1 year is 365.25 days. So 365.25 days over 1 year is 1. Similarly, 1 day is equal to 24 hours. 24 hour over 1 day is 1. 1 hour contains 60 minutes. So 60 minutes over 1 hour is 1. Similarly, 1 minute contains 60 seconds. See, this year goes with this year. Let me use another color. This year goes with this year. This day goes with this day. This hour goes with this hour. This minute goes with this minute. So what remains? In the right hand side, you have just seconds left. Now you have to multiply these numbers to get the number of seconds in a year. When you do it, what you get, I will write directly. You will get 1 year is 3.16 into 10 raised power 7 second. So you need to remember it. But check it at home. What you have to do, you have to simply make the calculation, multiply all the numbers in the right hand side of this equation. So you get this number. So first part of the question we have done, we have calculated the conversion factor from year to second or second to year. So 1 year is 3.16 into 10 raised power 7 second, right? So second part of the question, we have to convert the this is only portion of the first part, because we have to convert the conversion factor between light years and meters. We have only first converted 1 year into seconds. So let us move to the next portion of the question. The speed of light is, if you write it to 3 significant figures, it is 3.00 into 10 raised power 8 meter per second. Thus, in 1 year, light travels a distance of 3.00 into 10 raised to 8 meter per second multiplied by 3.16 into 10 raised to 7 second, which is equal to, I will change the color, 9.48 into 10 raised power 15 meters. Let me encircle it. Understand it first. I am saying speed of the light is to three significant figures, 3 into 10 raised to 8 meter per second. That means light travels 3 into 10 raised to 8 meter in 1 second. So in 1 year, light travels a distance of this much. We're multiplying speed of the light in meter per second with the number of seconds in a year. We are getting the distance traveled by light in 1 year, which by definition is 1 light year. So don't get confused. You know, speed is distance over time. So if we have to calculate the distance, we will multiply speed with time. We're supposed to find the distance traveled by light in 1 year. We're multiplying its speed with the time in the appropriate units. So we are getting the distance traveled by light in 1 year in meters. Therefore, by definition of the light year, I will write so that 1 light year is 9.48 into 10 raised to 15 meter. This is the conversion factor. So now we have calculated the part first. 1 light year is 9.48 into 10 raised to 15 meters. This much distance is called 1 light year. The first part of the question was to compute the conversion factor between light years and meters. For that, first we found the number of seconds in 1 year. Then we used speed equal distance over time to calculate the number of meters in 1 light year. So we have done part first. Let us move to the part second. The distance to Proxima Centauri star is, it is given, it is 4 into 10 raised to 16 meter. What are we going to do? We're going to convert it into light years. So we'll multiply it by 1 as we are doing it. 1 light year over 9.48 into 10 raised to 15 meter. Understand it? This is actually 1. We're multiplying this distance by 1 because 1 light year is 9.48 into 10 per 15 meter. That means 1 light year over 9.48 into 10 per 15 meter is 1. So what will happen? This meter will go with this meter. We will get our answer in light years. So you have to multiply 4 with 10 raised to 16. Then you divide it by 9.48 into 10 raised to 15 meter. When you do it, what you will get your answer as 4.2 light years. That means 4 into 10 raised to 16 meter, which is the distance of Proxima Centauri star, is equal to 4.2 light years. So we have done second part of the question. We have converted this distance given in meters into light years. That means what? That means light from Proxima Centauri takes about 4.2 years to travel to Earth. To travel to Earth. The distance is 4.2 light years. So it will take 4.2 years to travel to Earth, right? I'm writing about because there will be effect of atmosphere on the light. When we say 1 light year is 9.48 into 10 to the power 15 meters, we are taking here speed of the light in vacuum. So it travels 1 light year distance in 1 year, and we assume there is vacuum throughout. That's why we're writing here about, right? You need to check this number here, check it at home, and check this calculation as well at home, and this calculation as well. Check it. So this is all for today. I hope you're enjoying these problems, and do not forget to like and subscribe my channel. You can comment in the comment box. Don't waste your time. Thank you. God bless you. Assalamu alaikum.